In this section, we continue our introduction to network slicing, but in two practical examples. The first given example is deploying network slicing within the 5G network. We have already understand the different requirements of 5G at the beginning of the lecture. They are enhanced mobile broadband communication, ultra-reliable and low-latency communication, massive machine-type communication. These requirements lead to the design of the 5G network on the concept of end-to-end slice, including run and call network segments. These three types of network slices for different services are illustrated in this figure. We can see that different services will be associated with different slices depending on their requirements. Each slice will be configured in terms of topology, capacity, and services in order to satisfy the requirements of one or more specific service classes. The programmability and isolation properties of the network slices will enable the deployment of different network configurations and service functions. Isolation among network slices provided by SDN in order to allocate different functionalities and reconfigure the slices so that the requirements of different services are satisfied. NFV can be positioned in the core or in the edge cloud, depending on the requirements of each slice, and they can be subsequently interconnected through SDN. So Fig 16 proposed the example of 4 network slices dedicated to ultra-high definition streaming, mobile phone data services, massive Internet of Things, and massive mission-critical IoT. The ultra-high definition slice allows a mobile virtual operator to deploy its streaming service by deploying dedicated functionalities at the edge of the network. In order to employ resource management, reduce latency, and avoid network congestion. In the case of the phone slice, most functionalities are virtualized in the core cloud, like mobility and RMS service. Meanwhile, the massive IoT slice is simple. It's only employing light-duty services in the core cloud. But for the mission-critical IoT slice, in contrast, most services are moved to the edge cloud for minimizing transformation delay and improving reliability. Figure 17 presents a more detailed vision on how to implement network slice in 5G. So a hypervisor located in the core cloud, it manages virtual switching facilities, for example, vSwitches or virtual routers. Also, it performs provisioning of the virtualized services and network resources. SDN terminals are built between each virtual machine in the core cloud and the data central gateway router. The gateway router then performs mapping between this terminal and the corresponding VPN. The concept is the same in the edge cloud and allows to build the end-to-end slice required for different services. The second example is the Industry 4.0 use case. Considering the industrial IoT context, hundreds of thousands of sensors are distributed in the factory to collect the status of machines and factory condition. These sensors are also networked to enable the access and collaborations. The goal is to precisely catch the changes in working conditions and especially faults and abnormal operations in an early age. Intelligent algorithm will process those collected data to predict the conditions and the possible actions. Both the correct operational status and a timely reaction are critical to reduce or even avoid from unplanned downtime. Its realization requires a programmable network infrastructure provided by the future 5G enabling massive machine-to-machine communications, as well as flexibility to quickly adapt to a large fraction due to demand and situational changes. On top of a programmable infrastructure, network slicing can allocate dedicated and adaptive resources for the conditional monitoring scenario. In the figure, it shows that slice 1 can be allocated on demand to address the emerging interruptions as a critical mission. With the centralized control, the resources can be flexibly reallocated when the demands and network conditions change dynamically. The slice 2 is used to monitor other conditional traffic. The conditional monitoring application contains audio and video data, which needs a higher data rate than other sensors, such as temperature sensors. So on top of the SDN and NFV infrastructure, network slicing in combination with novel technologies such as compressed sensor or network coding, it can realize configurable slices to fulfill on-demand quality of service requirements of the Industry 4.0 use cases. So the last slide shows the references I used in this lecture. So if you are interested, you can also find it on the internet. So thank you for attending this lecture. Have a good day.